Good.
Okay, well, today we're going to, all right, so today we're going to talk about we're going to start in section 8.4. So 8.4 is on negative exponents. Very good.
Yeah, you'll find out. You just throw it away and get a different one.
Let me try it one more time. Nope, I'm going to throw it away. Okay. There, that's a little better. Okay, so 8.4, I'm going to abbreviate negative exponents. Okay, so let's start. Go ahead and open up your book to page 474. Page 474. So what I want to show you is what happens when exponents go down in value and the effect that has on the number that they equal. So if you notice there on page 474, it shows 2 to the 4th is 16. And then right below it, 2 to the 3rd is 8. So you notice, look at that, there's a pattern because it's related to the 2, right? So they keep going down the same amount. And then if you keep going far enough, eventually you hit to a negative exponent. And the negative exponent is still continuing that same pattern. It just keeps on going. So there's like continuity between a regular exponent and a negative exponent. So the big idea in this chapter related to negative exponents is simple enough. So b, that's our base number, to the negative n, so this is our negative exponent, equals, as you'll see based on that page 474, basically it equals 1 over b to the n. There's a fancy word for this. It's called reciprocal. I like to think of it as just flipping the number. So it's because right here we basically had b to the, well, not quite, but if you would have thought about, instead of having b to the n over 1, we're flipping. So that's where the flipping comes in. Yeah, so that's the first big idea in this section. So for an example, let's try this. So we've got, this will be our example. I'll call it example 1. So say we have a to the 5th times b to the negative 3. Okay, so this is going to equal, is the same as writing a to the 5th over 1. Does that make sense, everybody? Mm-hmm. Okay, so thinking about this, how would we write b to the negative 3? Well, what's another way of writing that?
It would be under 1. Or so like 1 would be over it.
Okay. And would it be negative or positive?
The 1 or
the 3.
The 3 would be negative.
No.
It would be positive?
It would be positive, okay. Yeah. So if you look here, so we have the base number to a negative exponent.
So then the top number is the positive reciprocal of, okay.
Yeah. Okay. Yep. Yeah. So yeah, so it's gonna be, so what we're gonna have here, we can kind of like, I'll just do a little translation here. So we have a to the 5th, the 5th over 1 times 1 over, this would be b to the 3rd. Does that make sense to everybody? Okay, so then well, how could we write that to simplify it?
A to the fifth over b to the third times b to the power of 3.
Yep, that's it. Very good. Okay, now we have another big idea that relates to this flipping notion. So we have, let me get rid of this. So if we have a fraction, like this, that's the same as, anyone have a guess?
Y to the power of n, and x would be over it. X over the power of, wait, hold on. X over y to the power of n.
Okay, so we're gonna do a reciprocal again.
Mm.
So it's gonna be y over x to n.
Oh.
So kind of like how we had the one, so instead of having the base over 1, we switched it to 1 over the base. So we're doing a similar kind of thing here. So you just flip them and then take them to the power. So we're going to do an example here. So we'll call this example 2. So we have, okay, let's do 6 over 5. So 6 over 5 to the -2 equals, anyone want to give me a start for that?
Will it be -10 or just 10 over 12?
Wait, look at the problem.
So look at what we did up here.
Yeah, no,
What?
don't take it that far. Start it.
Real?
5 over 6 to the power of 3.
Yeah, so it's going to be 5 over 6. So we did the flipping to the power of 2, which is
25 over 36.
25 over 36. Very good, man. And that's that. Now let's try something different. So let's try, let me get my example ready. So let's say we have one that's already set up a little different. So let's say we have 1 over m to the third, and then it's to the -4th. Okay, so let's think about how we would try to solve that or simplify it.
So first we flip it.
First you flip it, yep. Then what do you do? So you would flip it like we're saying here. So then it's to the 4th, right?
Mm-hmm.
So what would be the next stage here?
Would you add the 4 and the 3 powers?
No, not add. So another way of writing this, right, would be m to the 3 over 1 times m times 3. Lots of writing. that make sense?
Multiply by 4.
Yeah, you can just multiply this by 4 effectively, but yeah, exactly. That's exactly what you do. So then it's going to be m to the 12. Now for some fun.
Over.
So, oh yeah.
Over 1 to the 4th, remember that.
Okay.
I
One to
Yeah,
the
very
fourth.
good, man. Thank you. Thank you.
And what
Yes.
does 1 to
One
the
to the
fourth
fourth.
equal?
Yes,
We'll learn
thank
that
you.
eventually.
You'll learn that eventually. Good job.
Very good. I like it.
Keep on.
Okay, now we're on to a fun example. So I want you to imagine that it's currently 2077.
Oh,
So we're
Not that
far
far in
into
the
the future.
Not that far.
Not that far. Well, yeah, compared to the link.
so are we all like robots and stuff?
I don't know. Yeah, like we're what is it? Transhumanism or something?
No, India's gonna be the next superpower in 2077.
So we're all gonna be like big Curry.
Yeah.
I like Curry, so I'm fine with that.
Well,
Okay.
India and Central African countries. So, as Martin alluded to. Mr. Goff's other class.
Okay, so it's 2077. How many years from now is that?
52.
52. Yeah.
That's not that far.
So.
I'll
No,
only
it's
be like,
not.
I'll only be 65.
I might be a little
I'll be
old.
67.
So 52 years from now.
You'll only be like 100.
Yes, 100 and something, that's right.
Okay.
117 to be exact.
So 52 years ago, or 52 years from now, let's imagine that a person, we'll call her Sophia, which is the Greek word for wisdom. So Sophia invested money into a Roth IRA. Does anyone know what a Roth IRA is?
No.
It's
No.
a Roth IRA.
Yes, right. So it's the IRA stands for individual retirement account. And what's beneficial about these retirement accounts is that your money grows tax-free when you put money in one of these accounts. You don't get a deduction like in a traditional IRA, which would reduce your tax bill, but you do allow your earnings to grow tax-free. Anyway, so that's what a Roth IRA is. But at 52 years from now, she invested today. Yes, Matt.
When do you set one of these up? Like as soon as you start working, or?
So you can set a Roth IRA up as soon as you have taxable earnings.
Okay.
Yep. So you can't put in money until you have taxable earnings.
Yeah.
But then you can put up to the amount of the of your earnings or 7,000, whichever is smaller.
Okay.
So anyway, so we've got at 2077. Her account is currently worth a lot of money. Okay, 200. I mean, not that much money, but quite a bit of money. $236,077. Going down to the penny. Okay, and 44 cents. Okay, but remember, this is 52 years from now.
That's fucking nothing.
So the question is, given that she's earning a 7% return, which if you invest in the stock market, historically the stock market earns about 10% return per year, but there's inflation, which reduces your purchasing value. So that would make it
About
about
how much
7%, about 3% per year is the inflation. So that reduces your value to 7%. So what we want to figure out is what she invested this year, 2025. So what did she invest in 2025 that ends up being this much? Does anyone have an idea how we might set this up using negative exponents?
Decay? Somewhat.
Yeah, in a sense. Well, not really. Yeah, okay. So
It
let's
is.
let's
It
think
is.
about the.
It is decay.
Yeah, it would be. It's a decrease. Yeah. Okay, so let's think about this. So this is
What's your formula?
yeah. So we've got 1 point. So we initially took our original amount and we multiplied it by a factor of 1.07, right?
You have the 100%, and then there's 7 because inflation.
Correct. Yep. So
So make that.
so initially we did 52 years from whatever this initial amount was, right?
Right.
So if we're starting with this amount, what the negative exponents allow us to do is to go back in time
52 years.
from today, right? Because it's 2077.
That's confusing.
Yes, it is. Okay, so yeah, so if it's 2077 and we have this much money, then if we go back in time 52 years, we'll end up with our initial amount that we invested in 2025.
Around 7,000.
Yep, 7,000 is correct. Yep, so this is 7,000, which just so happens to be the maximum amount you can put in to a Roth IRA in 2025. So yeah, so if you invest 7,000 today, in 52 years, you'll be able to buy $236,000 worth of goods. Hopefully, if everything works
You
right.
did nothing for that 50, so,
That's true.
Yep.
so if you think about it,
And she didn't put any more money in.
Nope.
That was just okay.
Yep.
nope, she didn't put any more money in there, it just grew as she, for 52 years.
Yep.
But it grew for 52 years, and a lot of people, if you start out young and you put the $7,000 in and just leave it alone, it will grow while you're letting it do that.
Yes, Matthew.
In a TV show, in a cartoon or whatever, the main character fell into a time machine.
Okay.
Futurama. And the main character fell into a time machine and went or a cryostasis chamber actually. And he went, I don't know if it was 1,000 or 10,000 years into the future. He had a savings account which had 82 cents in it. And when he woke up in the future, he had what's it? $2 quintillion.
Yeah, I think Einstein called compound interest a miracle or something to that effect. I can't remember exactly what he said.
Not that rich. I mean, you could maybe buy a couple groceries.
You could probably have a whole world. Yeah.
Okay, now we'll move on to example 4 though. Okay.
Does the bank even have that much money?
No. I mean, maybe $1 trillion, a couple $1 trillion, but I mean, oil companies in Saudi Arabia definitely have trillions of dollars. Definitely.
They're just not public about it.
Yeah. What are you guys doing?
What if you did like an Arabian?
What are you guys doing?
What if you did like an Arabian Prince scam on an Arabian Prince, and then you got them to send you like billions of dollars because they're rich oil tycoons, you know?
Because they don't care about money, so you.
Yeah, they really don't care about money. They
Yeah.
just like hand out free Rolls Royces or whatever. It's like Bugattis or something. 3 Reese's.
Rolls Royce. It's a watch. To tell you
Okay.
time.
No, a Rolls Royce is a car. A Rolex is the watch.
Oh.
All right, we're gonna try something different now. Keep on the theme of negative exponents. So we want to simplify this rather messy piece of numbers here. Okay, so let's try to break this down into the component parts. So we've basically got 3 over what? Times what? A to the second power over A to the fourth power, right? So that's A to the second, A to the fourth, times B to the fifth over B to the third, times C to the third over C to the fourth. Okay, so this is the same. This can simplify down to what? 3 over 18 is the same as
1 over.
1 over 6. Yes, 1 over 6. Okay. A to the second over a to the fourth is the same as what?
A to the 6. No, A to the 8.
No, because you're dividing.
Oh, 1 over A.
Oh
to
yeah,
the
you're
second.
right.
Whatever
Yeah.
two- yeah,
Oh, I
half.
forgot we were dividing,
Half.
not multiplying.
So it's 1 over a to the second. What's another way of writing this?
Just A. Or A times A.
Half A.
Let me give you a hint. What is this lesson on?
Negative. Oh, okay. Well, it didn't really help me specifically.
1 over a squared is the same as what?
Oh,
A
8
squared to the negative.
of 1.
A to the
You're close,
negative
not
2.
A to the negative 2 over 1, which is a.
So this, yeah, this is just another thing. It's the same as a to the negative 2. So like we normally do, we're subtracting. See how that makes sense? So we have 2 up here, minus 2 below, or minus 4 below gives us negative 2. That makes sense? Now, for our simplification, we'll just leave it as the 1 over negative 2. But I'm trying to show how this works mathematically in here. So then here, we've got b to the 5th over b to the 3rd. So what's that?
B to the power 2.
B to the power of 2, yep. Okay. What would the next one be?
That looks like a fish.
It's a 4.
C to the negative 6 power.
A
Is that a
3.
9 or a 4?
This is a 4, I believe. Let me double check here.
Whoa.
Yep.
That makes it even worse.
Yeah. Well, never mind my nose. I thought that was a 9.
It's like a
Sorry.
cat.
3 minus.
So
C to the
3 minus 4,
negative
very
one.
good.
C
Yes.
to the negative 1.
Yeah, so this is, I'll put it down here just to keep us consistent. So that's the same as c to the negative 1, which is also the same as 1 over c. Does that make sense?
Yes.
Okay, so we've got this now. So now let's see if we can put this all together into one simplified number here. So we have a 1 here, we have a 6 here. So we know there's not a 6 on top, there's a 6 on the bottom. So we know we've got a 6 on the bottom. Okay, then here we have a 1 on top again, and we have a 2 on the bottom. So it's going to be a2, or a to the power of 2. Any guesses what we're doing with this one?
Keep it there.
Yeah, effectively we're going to put it on top, right? And then for this one?
Just C.
And I think that looks correct to me. Right?
6, 8.
Yep.
Grade.
That is it.
Stack.
Okay. One more example for section 8.4. Okay, let's see. Okay, so we want to simplify y to the negative 7
Oh.
2. We're gonna do something fun. Okay, so
That makes total sense. I'm lying.
It does.
So let's break this down. So you do exponents first in a certain sense. So let's figure out what this is here. What does that effectively equal? Part in the parentheses. So we'll just put it over here. Y to the
Y
negative 7
negative.
equals.
Would that be equal to y to the power of 7 with a 1 on top? Or so 1 over.
Yep, the 1 over, yeah, 1 over
Sorry,
y to the 7. That's
I made
it.
that.
No, that's fine. Yeah, so that's it exactly. So that's what this equals. Okay, so we know that's effectively what's here. So we have 1 over y to the 7. And then we have it to the power of 2. So what does that work out to? Let's just take it one step at a time. Man?
Would we times 1 times 2 and then y to the 7th power times 2? Or would it
I
be
wouldn't call it times.
adding
No,
the
no.
So I would think about it like this maybe. So you have 1 over y to the 7, okay? And then we have to times it, its power, to the power of 2, right? So we would have another 1 over y to the 7. Does that make sense? Because it's to the power of 2.
1 times 1 is 1, and then y to the 7 times y to the 7 is.
y to the
Yeah.
So effectively, right, it's basically just these two numbers multiplied by each other for the exponent, right? So it's the same. This also equals y to the negative 14. See that pattern there? Any questions about that pattern?
That makes sense.
All right.
Does it matter if it's positive or negative?
Yes. You mean this number here?
No, if you're timesing those two together, it's negative 14. Oh, okay.
Right, yeah, because you're gonna get 1 over y to the 14.
Right. See here.
And then you flip it around. Okay, yeah. Grayson had a question.
Oh, go Grayson.
If that were to be instead of -2, would that just be y to the power of 14?
Very good.
Because 2 negatives cancel each other out.
Well, because you're flipping it once and then you flip it again.
Yep. Good question though.
That was a good question, Jason.
Okay. All right, I think we're on to 8.5. So 8.5, you may know the vocabulary, but I now know the vocabulary. We're talking about powers of products and quotients. So does anyone know what a product is?
The product of two numbers being multiplied together.
The product is
Yep.
something that a company makes.
Right. Yeah, that too. Gotta love the English language, right? Okay. So powers. So 8.5, 8.5, powers of products and quotients. So products, like Matthew was saying, are just multiplied numbers, and quotients are just fractions.
I thought they were the deeds to the house.
Quotients?
Quotes.
Oh! That's funny.
Getting a quote for
Oh,
the
yeah.
house or something.
Okay.
Those are things in a newspaper article.
No, those are things that are said
Yeah.
in speeches and recorded.
Yeah, go back to math.
So here's our first big idea. So we have number 1, A, multiplied by number B, and this is to the power of n. So what does that equal? Anyone have a guess?
It'd be a to the power of n times b to the power of n.
Yep. Okay, so let's try this with an example. So we've got negative 3x Okay. How do you think this would work? So what are the two components here? We've got thinking about this.
-3 and x.
Okay, so we've got -3
Times
x. And then what's going on with
3
the exponents?
times. So -3 times x times -3 times x times -3 times x.
-3 to the third power.
Thank you.
Oh,
And then what would this be?
The same.
Yep. Okay. Does anyone know what that works out to? What's -3 to the third power?
-27.
-27.
Did I even notice? Oh.
Yeah, so that's the answer. See how that works? Okay. Let's try something a little more fun.
Fun for you.
Fun for me. It's fun. Math is fun.
I'm happy.
I'm serious. Okay, let's see here.
It'll only be fun when she teaches me how to do whatever it's called.
The lambda or whatever it was
Yeah.
called.
Lambda calculus.
What are you gonna major in college, Matthew?
I'm not going to
Oh,
college.
you're not?
Yeah, no, it's trade school.
Trade school? Okay. Electrician, right?
Yes.
Gotta start working out.
I am.
Oh, you are?
You go to gym.
Yeah. Private gym. Private trainer.
Dang.
Though I am taking a break since I can't really do that during driver's ed.
Is that a Z?
This is a 2. This is a z. You're right.
Exactly.
Put
Oh,
a,
that is
put
easy.
a line through your Z. That helps you to identify.
Yeah.
Now there's no more Z.
Okay. So, how do you think this works? Given our little a.
Would it? Well, so for the x, would it be x to the power of 6?
Yep.
Okay.
What about the first number here?
That'd be to the power of 2, right?
So it'd
Which
be
is the
negative
same
4.
as.
Which is
Whoa.
No.
What's -2 times -2?
-2 times -2 is
Negative 4.
4.
Negative
4.
4. Yeah, it's 4.
My brain is.
Okay. Yeah. Okay. So yeah. So 4. Okay. What would the y be?
4.
Yep. Y to the 4th.
Wait, but the power is a negative.
The powers are positive here.
Yeah, but the
On the
power to
side.
the power is not negative. But you said that it would be
Positive
4.
times a positive is a positive.
Yeah.
Negative.
So, but a negative times a positive is a negative.
It's not a negative times a positive. It's 2 times 5.
Are we talking about y or are we
We're
talking about z?
-2.
Negative 2 on the left side.
Yeah.
How did we get 4 if the whole thing and that power over there is not negative?
So -2 doesn't really have an exponent. Well, I mean, I guess it does in a sense. But we're just taking -2 times itself, right? To the power of 2.
Oh, that's right. 'Cause
Yeah.
it's not.
We're not. Okay.
I was thinking the same thing as you, Matthew.
Yeah.
Yeah, it's not one of the regular exponents here, or variables, I guess. Yeah.
Then why on my calculator, when it's -2 to the 2th power, it's -4?
Because no, we're timesing -2 times -2.
Yeah.
So
If you
how
put
would-
parentheses around the -2, I think if you took it to the power of 2, it would give you 4.
Yeah, I'm gonna take this calculator.
You're
and do
taking the whole -2 to the power.
Oh yeah, you're right.
Okay. Yep. So then what would the z be?
To the power of 10.
Put my little z marker there.
Oh, crap.
This looks like a 16. Yeah. Okay. Okay, so that's related to products. So now let's think about quotients, which again, quotients are just fractions. Every field has its vocabulary, and you have to figure it out. Okay, so we've got, so we have, instead of A times B, we have A over B to the N equals, anyone have a guess? Ed?
I mean, is it a to the nth power over b to the nth power?
So yeah, so we're just dividing n.
Does this
So
make
it's
sense?
just
Because this
one.
is just, if you have, like, if this was 2, right? So like, if this was A over B to 2, that would be the same as A over B times A over B, which equals A2 over, or A to the power of 2 over B to the power of 2. See how that works? How this all works together?
Yes, sir.
Okay, so let's try this then. So if we have 2/3, let's say it's to the third power, that's going to equal,
2 to the power of 3
okay,
over 3 to the power of 3.
okay, so 2 to the power of 3 is 8, right? 2
Yeah.
times 2 is 4, 4 times 2 is 8. 3 to the power of 3 is what?
27.
Yep. Okay, now I want to ask you something. So let's pretend we have negative 2/3, and it's to the power of, we did this earlier, 52. We didn't do 2/3 to 52, but we did our retirement account for 52 years. So if we have this exponent here, is this number going to be positive or negative?
Positive.
Why?
Because it's just like how the other one was, right?
Oh,
The
yeah.
other -2, it's still surrounded by the parentheses. So
You have
it's
negative
timesing
2 over
itself.
3 times negative 2 over 3, 52 times.
Yeah, so if you have an even number of negative 2's multiplied by each other, you're always going to get a positive number,
And if it's
right?
not even, then
You get a
You
negative.
get a negative, yep, if it's odd. Yeah, so if you had negative 2/3 to the 51st,
And it would be
-2.251.
yes, yeah, so it's negative, exactly. So this just works in general. So if you have an even exponent on a negative number, you're going to get a positive number. And if you have an odd exponent on an even number, you're going to get
if it's
an odd exponent on a negative number, excuse me.
if it's a positive number and you have a negative odd number, would you get a negative? And then is it the same for if it's a positive negative? I mean an even negative?
What did you ask me?
So he's asking about negative exponents. It's
the
still the
same.
same principle,
Mhm,
right?
it's the same principle.
Yeah.
So
So if it was an even negative exponent, then it would be positive.
okay.
And if it was an odd negative exponent, it would be negative.
Well, I'm saying on a positive.
So are you talking about this or are you talking about this?
This. Yeah.
This.
If that was
Negative.
positive
Oh, it was positive.
and the power was a negative even, would that be
It would be
that-
positive.
okay?
Yeah, it would still be positive. So if this was negative 52, like that, okay, that would be the same as 3
Oh yeah.
over
no, I see
2
that.
to the 52nd. Okay? Yeah. So that's still a positive number, even though it's a negative exponent. Yeah. Might actually be a okay size positive number actually, if you're going up that. Okay. All right. So we are to. Is it break time?
Oh, is it?
Yeah.
Oh, is it?
Okay, break time.
Can you translate for me now?
Yep.
Hit the little square.
And